Well, hello again everybody, and today we're going to be finishing off our run of hot stuff videos, but we're not going to be looking at the soldering of surface mount devices. Let's face it, surface mount is never going to catch on. Instead we're going to be looking at desoldering through-hole components in the form of the Hakko FR-301 desoldering gun. But before doing that, let's look at some alternative, perhaps more traditional and cheaper solutions to removing through-hole components. I started my adventures in electronics more than 40 years ago, and I'm sure you've heard it said that they were simpler times, and it's certainly true when it comes to electronics. So just looking at this typical circuit board, I'm guessing that this was probably made in the early 70s or perhaps even before then. Just looking to see if I can see any date codes on anything. No, unfortunately nothing obviously stands out, but just looking at the mix of components on here, you can see that we've got a range of transistors. You can see a few here, got some capacitors, got some fairly large sockets, and also got some variable resistors here. But most of the devices are actually relatively simple in that I think most of them haven't got any more than 2 legs apart from the transistors. The transistors have got 3 legs of course, and of course this big socket has got a lot of legs. But it's a relatively simple board. The components were simple, they didn't have many legs on them. Just turning the board over, you can actually see, if I just rotate it, the tracks are actually only on one side of the circuit board. They're on the underside because this is a single-sided circuit board. Now of course it's quite normal to have to remove some of these components in the course of maybe doing a repair, but I think actually back in the day it was actually even more important to be able to remove components. And the reason for that is because many of these electronic components, they really weren't available to the amateur electronics engineer. So what we had to rely on doing is we used to do things like go down the rubbish heap and we'd collect old televisions and radios, we'd take the circuit boards out, take them home, and we'd have to remove the components. Now for simple through-hole components that only have a couple of legs, of course the easiest way to do it is just take a soldering iron and we can actually just heat up the joint and we just pull on the capacitor and it melts the solder and it comes out. If we can actually find the right joint to heat up, is it that one? There we go, so of course that comes out without any problem. And the same for this green coloured polyester capacitor, hopefully we can just walk that out. And much the same for this resistor here, although the legs might get a little bit hot, so you might just want to use a screwdriver or something just so you don't get burnt. And of course those come out absolutely no problem. Now the heating and component wriggling technique, this works perfectly well for components that just have a couple of legs, but it does actually get much harder to do as the components start to gather the number of legs. So in the case of this transistor here, which I'm just looking at it, I think it's got 4 legs. If we actually try to do the waggle technique, we're going to fail, but let's try it. So I'm just going to heat up one of the pads. And I've actually managed to move the transistor a little bit, but unfortunately what's happening is the legs around it are actually stopping me from pulling the transistor out. Let's see if we can heat another one up. Okay, I did actually manage to get a bit of movement on that. Let's just keep going, waggling one leg at a time. Oh, almost there, and we got it. So again, we can actually use this waggle technique to remove transistors and things of that nature, but there reaches a point where if the component's got a lot of legs, that won't actually work for you. So again, let's look at maybe a more later circuit board here. This one's got some integrated circuits on it. Let's look at this IC here. And one thing that we can't do is we cannot use the waggle technique on this. So although I can actually heat this joint up, and I'm going to put a screwdriver under one edge of the chip here, just so I don't get burnt. I can actually heat up this joint, I can actually put some pressure on it, but nothing's actually moving because unfortunately the component is being held in by the solder which is on all the other pins of the IC. So it really doesn't matter how much I wiggle this around, I'm really going to struggle to actually get this IC out. If we only want to remove this IC and we're not actually bothered about reusing it, the next easiest thing to do is actually just try to cut the legs off it. So using a pair of small and quite sharp side cutters we can do that. And then if you're quite lucky, what you can do is you can just tin the end of the soldering iron here, and if you just actually touch the end of the soldering iron to the leg that we've just cut off, there's just a little stub of metal here, and usually, well, I've just done it there, you can see that the actual leg, it's melted the solder and the leg has just come out, because the actual surface tension between the leg, the solder and the end of the soldering iron, it's enough just to actually suck that leg out. So all we have to do is we have to go along this IC one pin at a time, and we can remove those legs. Now unfortunately there might be some occasions where you do actually have some trouble actually just removing the old pins out of the circuit board, in which case what you'll have to do is you'll have to wait until your wife or girlfriend goes outside and then go and borrow her finest pair of eyebrow tweezers. In which case you can actually remove these pins really very easily. Now although this technique might actually look quite messy, it is actually reasonably fast, and one of the advantages about this technique is although it might actually look a little bit destructive, it's actually very non-damaging to the circuit boards. Well, at this point in the proceedings you can see that I have gone ahead and I've removed all the IC pins, but everything looks quite messy. Now unfortunately the actual holes where the IC pins went through the board, you can see that they're actually plugged up with solder, and that can be quite difficult to remove. Now back in the day what I probably used to do is I used to hold the board up to my face with the soldering iron, I'd heat the solder up and actually just blow through it. Now I can't possibly show you a technique quite as dangerous as that in this modern world of health and safety, so I'm going to bring on a next of our desoldering aids, which is actually to use some desoldering braid. So I'm sure that most of you have actually used desoldering braid, but for those of you that haven't, all it actually is, it's very fine copper wire here, and what it actually does is it actually sucks up the solder like a big sponge, and sometimes we just need to add this little bit of flux because it does just help clean out all of those holes. So that's what I'm just doing now. Now this particular circuit board that I've chosen, it's a very early through plated board and it's got very small pads on it. Now it's almost impossible to remove these ICs any other way without doing damage to those pads. So although this is quite an old school method, there's certainly times when you're going to have to use it. So our solder braid can actually work very well for mopping up solder, and it does work well on single-sided boards. So going back to the transistors that were just a little bit more difficult to remove, again what we can do is we'll just use some solder braid, and again I'm going to apply some flux, mainly because this board is such a very old circuit board. I can see that the joints look horrible and kind of quite corroded and oxidised, so let's just add some flux. And I think that's effectively removed all the solder from the pads of our transistor. Hopefully I've got the right pads. And the transistor really just drops out very easily. So our solder braid does in fact work wonderfully well on these single-sided boards. So here's a double-sided circuit board, and as you can see we've got various 7.4 Logic series chips on here. Just turning the board over, you can see that all those components, all those ICs are actually soldered on to the underside of the board. But because this is a double-sided board, if you actually turn it over, hopefully you can actually see that the component legs are actually also soldered onto the top side, because these boards are actually through plated. They've actually got almost like a little tube of metal which joins the underside of the board to the actual top side of the board, and if you look very closely you can actually see that there is like a little blob of solder that's actually come through from the underside to the top side. So the problem is that when you try to use solder braid to actually remove the solder from a double-sided board, although you can actually remove the solder from the pads on the underside, it can actually be quite difficult to remove all the solder, because you've got to try to drag the solder that's mounted on the top. You've got to drag it all the way through the board so you can remove it on the underside. That usually doesn't go so well. Just as before, let's add a little bit of flux because it makes everything easier. Let's go in with our solder braid now. Well, having complained about the effectiveness of solder braid on double-sided boards, well, you can actually make it work, but one thing you do need to check is to make sure that all the pins have actually had the solder removed. Now I'm just giving them a little bit of a press here. Now some of them do seem to be still remaining firm, like that one. This one will move, but actually that one still seems to be pretty stuck. However, we can see on turning the circuit board over that we've actually still got solder on the top side of the PCB, and that solder is still going to be holding this IC in place, unfortunately. I've turned the board over. I'm just giving the pins a little bit of a prod just to make sure that they have all come loose. I thought that they had. So after all my complaining about double-sided and through-plated boards, it turns out that our solder braid did actually do quite a good job of removing this IC. So we can actually see that there's absolutely no damage here to either the pads, or from what I can tell, I think all of the through-hole plating is in pretty good condition as well. Let's turn the board over. And again, you can also see that there's no damage to the top side of the board. Now, I think one thing that really was in our favour is that, as it happens, there was actually a fair amount of clearance between the actual legs on the IC here and the actual holes in this PCB board. Now, sometimes that won't be the case, and it doesn't really matter what form of desoldering technique you use, apart from cutting the legs off. Sometimes you'll find that the actual holes drilled into the board, they are just really small, or maybe the through-hole plating could be thicker than expected, and in some cases, whatever you do, you're just not able to remove all of that solder, and the component will remain rather stubbornly stuck. But in this case, we do appear to just have a little bit of clearance around the leg of the IC, and it came out no trouble. And finally, before I move on to the meat and drink of our video, which is actually sucking the solder away using various tools, we're going to use one final technique which sometimes you will get away with if the gods are smiling on you. So what I've got here, I've got a piece of fairly thick copper wire, and what we're going to use this as a thermal shunt. So I'm going to take our piece of thick copper wire, and I've actually bent it so that it will actually just surround and come in contact with all the pins of our IC. So what I'm going to do is I'm going to just put this over, I'm going to push it down now, so that hopefully it is now touching all of those pins. Now, you actually need a fairly powerful soldering iron to do this, and you probably want to turn it up. If it's adjustable, you actually want to turn it up to a fairly high setting. So I'm going to take some solder now, and I'm actually going to run it onto this copper, and I'm going to actually solder all the pins to this copper bar. Now, of course, you may also choose to use some flux of your choice. So what I'm going to do is I'm just going to work my soldering iron now. I'm working it down both sides of the chip, and if I'm very lucky, this copper's going to get really hot, and it's going to stay hot enough for a while, and it's actually going to keep transferring heat into these pins and down the legs, and hopefully it's going to be melting the solder on the underside of the board. Now, the only problem I've got is that this is only a little tiny board, it's difficult to get hold of, so I need really an extra hand to try to just prise this chip out now, and yeah, that's what I'm struggling with. Can I actually get under it? And let's just repeat with the solder wick. So this technique of using a piece of thick copper wire as a thermal well, it does actually work very well. I actually made it look harder than it actually is to remove a component, just because this board is small and it was just rocking around and I had trouble grabbing hold of it. Now, back in the day, you used to be able to buy special soldering iron tips which kind of replicated this piece of copper wire, but unfortunately you needed a different type of tip to remove every different size and shape of ICs, and some of those tips were really very expensive, so it wasn't ever something that I could afford to use. But everybody's got some old scrap copper wire lying around. This is just a piece of earth wire from a piece of twin and earth. Just strip it down and you just basically make one of these thermal wells or a thermal shunt. You make it to fit round the chip, and you can pretty much remove anything that's got exposed pins. Now I've also got a circuit board here that's got some surface mount components on it. Now you can actually use exactly the same technique to actually remove any of these ICs as well. All you need to do is you just take your piece of copper wire and you just have to shape it to fit all the way around. For example, just shape it in a square shape so it fits all the way around this IC so that the copper is in contact with the little legs like that. And all you'd actually have to do is you just work round with the soldering iron and then maybe just use a vacuum pickup tool just to lift the IC off. And again, it will come off very, very easily. And again, that's maybe a useful technique for those of you that don't have things like hot air stations. So as you can see, there's several techniques that we can use to remove through-hole components. Solder braid itself is actually very cheap, and depending on the brand and also the thickness of the solder braid, or the soldering wick as they actually call it here, you can actually have it from between just a couple of pounds and maybe £5 for about 1.5 metres. But if you've actually got a lot of components to desolder, you can actually go through this desoldering wick relatively quickly, and it is also quite a time consuming technique. So for those of you that don't want the time and trouble of using solder braid, you might prefer to be sucked off. So on the bench here you can see my small collection of desoldering pumps, or as I like to call them, solder suckers. Now as it happens, this particular solder sucker probably happens to be one of the oldest tools in my collection, because I seem to remember that my grandfather bought me this at the age of probably about 10-year-old. So this actually makes it over 40 years old, and it does actually still work. Now a solder sucker is a relatively simple device and it's a vacuum tool. So the way that we use this is we use a soldering iron to actually heat up the solder and the pin that we want to remove the solder from, and then basically we touch this end of this nozzle here against the circuit board, and there's a spring and plunger affair inside here. So we press the button, the plunger flies backwards, it creates a vacuum which actually sucks up the solder into this chamber here. And you can see that when I push the plunger forward, it actually does lock into position, and it gets released by just pressing the button here. Now you can also see that this little rod also comes forward when I press the plunger forward. Well, the purpose of that is actually to remove any solder that may be blocked up now. You may have sucked some solder into here, but it could also block up the nozzle. So as you actually push the plunger forward, this rod pokes forward and it actually cleans any solder and expels it out of the end of the desoldering tool. It squirts it out the end. My three solder suckers here really all work in pretty much the same way, although you can actually pay quite large price variations. And what I've actually found is that the actual cost of the solder sucker, it doesn't necessarily compare to the quality of it or how well it will actually work. So you're probably going to find that you're going to have to kiss an awful lot of frogs before you find one that's going to work for you. So we're just going to take the desolder sucker. I'm going to have a go again at this single-sided board. I think there's a transistor there that we can pull out, so let's just have a go at that. So you are going to need a soldering iron because it relies on removing molten solder. You can't actually suck the solder up when it's dry, so let's just do that now. Let's heat up the solder. So I'm just going to heat up the solder using a soldering iron. And now you've got to have a little bit of dexterity here, in that what you need to do is you need to move the soldering iron away, and then you've got to be able to put the little nozzle of the solder sucker over the pin and the pad, press the button, and if you're lucky and the gods are smiling, it will suck up that molten solder into the desoldering gun. So let's try that. So looking down now, I can actually see that all of the solder that was actually holding the pin onto the pad here, that's been molten. It's been sucked up into the solder sucker, and I can now see that that pin is actually free to move. So yes, we've vacuumed away all that hot solder. Now sometimes if you're working on old circuit boards, you might actually find that it's easier to reapply some solder over the original joints, and that can be especially true if you're actually working with unleaded solder, because that has quite a high melting temperature and it actually tends to set very quickly. And I think that's actually our transistor desoldered now. So I'm just giving the transistor a little bit of a wriggle now, and I can see that all the pins actually are moving freely. So it should now just be a matter of actually pulling the transistor out, and comes out easy as that. So let's have a go now at removing this IC. We're actually going to go from one of my cheapest solder suckers here that probably would set you back around £5 or £10 to the most expensive one that I've got, which is made by a Japanese company called Engineer, and these retail at around £20, but you can't really argue with the quality of the construction. They are very nicely made. A couple of our solder joints here are just proving a little bit stubborn, so I am just going to reapply some solder to those joints. And after removing all the solder, I'm just giving each of the pins just a little bit of a nudge just to make sure it is moving and it is free. It should just come out now. There we go. A warning on the use of solder suckers comes all the way from Sir Isaac Newton in the form of his third law, in which he states that for every force there is an equal and an opposite force. Well, what happens is when we actually press the button here and the plunger shoots backwards, sucking up our solder, the actual tip of the solder sucker will be driven forward into the circuit board. Now that's probably the worst possible time that you want to hit those superheated pads with the end of your solder sucker, and what can happen is the tip of the solder sucker will hit that pad very hard, and in some cases it can actually dislodge the pad or actually damage the track itself. So let me demonstrate that by putting the solder sucker up to the edge of our board, which is just represented by a 10p piece. Let's fire that. Let's take another solder sucker because they're all a bit different. A trick that an old boy taught me, that when using one of these desoldering tools, it helps to actually put the board onto a soft surface, and that means that when you actually fire off the solder sucker, the board can actually wobble, it can move slightly, and that means that not as much energy is going to be transferred from the nozzle onto these pads, and that's much less likely to cause damage, and hopefully you won't then knock these pads off. For 90% of the desoldering that I have to do, I can usually get away with just a small selection of these desoldering wicks and one of these mechanical solder sucking pumps. But there are occasions, for example, where you might want to remove quite a lot of ICs. It can actually involve quite a lot of sucking and pumping to actually get all that solder removed from the circuit board. Now there can also be other occasions, for example, where you get a board that may have quite a large ground plane, and what you might find is when you're actually trying to remove the solder, the actual ground plane, what it will do is it will suck all the heat away from the solder joint and it will go cold very quickly. Well, as soon as that solder starts to go cold, it's going to make it more difficult, or in fact impossible, to suck up. So really, wouldn't it be great if there was a way of actually heating up the solder joint and actually sucking the solder away at the same time? If only somebody could invent such a wonderful tool. Well, for those of you that are still watching, well done. And finally, it's time to take a closer look at our Hakko FR-301, and it's a portable desoldering tool. And as you can see, the unit does come in one of these plastic hard cases. Let's just turn it round before we open it. And on the rear of the packaging, we've got a chart which shows us a number of different desoldering nozzles that we can choose from. Because when you're using one of these desoldering guns, it's important to have a nozzle which actually fits the legs of the components that you're actually trying to desolder. And generally you're looking for a nozzle size that's got a hole in it which is just slightly larger than the leg of the component you're trying to desolder, and something which actually fits nicely onto the component's pad. Now we can also see that we've got some specialist nozzles here, so these are extended reach for if you've got to reach down in a difficult place on a circuit board. So I think we'll actually keep hold of this chart, because I don't know about you, sometimes I struggle to know what soldering iron tip will do what, so that's a useful thing to keep. So just opening up the box, I can see that the box contains a couple of pieces of paper. One of them looks like some kind of a warranty statement, so we'll get rid of that. And the other one is some operating instructions. Well, I wouldn't exactly call it a manual, it's kind of just more of an actual pamphlet, but it does actually contain, I guess, the main salient operating points for this equipment. Yeah, it's not a complicated device, so I'm sure it isn't going to be too difficult to use. I'm not really a big fan of these plastic blow moulded cases because I kind of find that they generally don't actually fit the contents very well. Personally, I think I'd rather just have a box that we can throw things in, but yeah, this is what they've got, and I'm sure that putting all these components back will be something like the Krypton factor. So we can see we've got the gun itself, so I just have to pick that up now. Oh, actually, I'm quite pleased already. I was actually a bit concerned that this would be a little bit hard to manipulate. I thought it would actually be really quite heavy, because what we've got in here is we've obviously got a heating element for the actual desoldering part of the gun, but we've also got an electric vacuum pump. So there must be, you know, a relatively powerful electric motor in here. And I think my concern was, because we have got a big electric motor in here, I thought that the handpiece would be really, you know, quite heavy and maybe a bit difficult to manipulate, but yeah, that almost weighs nothing. In fact, I think let's just go ahead and weigh that now, because it is surprisingly light for its size. So the handpiece weighs about the same as a grey squirrel, but for those of you more familiar with the metric system, that comes in at around 550 grams. So just picking up the unit, it really does feel very, very comfortable in the hand. Certainly it fits my hand very well, and just giving the unit a bit of a pull and a twist and a squeeze, it really does feel very, very solid. You know, it has that quality feel about it. Some plastics don't, but yeah, this one feels very rigid. So let's have a quick look round. So we've got a trigger here which says vacuum on it. So I'm guessing when we press that, it's going to actually turn on the vacuum pump and it's going to suck the solder up. Then at the bottom of the handpiece, I can see that we've got a little dial and it's got the numbers 1 to 4. So this is actually the temperature setting. So it looks as though it's got 4 temperature settings, and we'll check those later. I'm guessing that this is maybe an indicator lamp that shows when the unit is powered up. And then we've also got what looks like a main on and off switch. Got to admit, that on and off switch isn't very easy to operate. It's kind of recessed, and I guess I've got relatively big fingers, so if I just try and press that now, I'm actually having trouble switching it on and off. But maybe that's a safety feature, so it doesn't get switched on accidentally. I'm not sure. Maybe that button should stick out a little bit more, but yeah, if I just use the end of my finger, I can actually operate it. So I'm guessing that this is the business end here. So this is kind of the soldering iron, but unlike a normal soldering iron, the actual centre of this tube here, it's actually hollow, so it's actually a tube, and you can see that we've got a desoldering tip here. So the hot end of this, well, it's going to get red hot because it's a heating element. This is going to melt the solder, and then because the actual tip here has got a hole in it, when we actually press the button, it's going to turn the vacuum pump on, and in theory it's going to suck up that hot solder into this waste reservoir here. So the molten solder that's been sucked off our circuit board, it's going to collect into this waste tube here. Now I've actually used a fair few desoldering tools in the past, and particularly one like the Dura tool. The actual waste tube can be quite difficult to remove, so we're just going to have a go at just trying to do that on this one. So I believe what we have to do is just going to push this spring-loaded clip back. So I'm going to do that with both thumbs, so I'm just going to push that back. As I push that back, this clip seems to actually latch into place because this little button has popped out. So now we can actually remove the waste tube, because this is going to be full of solder that's been collected. So we can see this is the end that the molten solder enters, and at the other end I can see that there's actually a filter element, and I'm guessing we should be able to pull this off because it's flexible rubber. So yeah, there's our filter element. On the opposite side of that, there's what they call a pre-filter, which is just kind of like a metal bowl which is designed to catch the molten solder as it gets squirted into this little vacuum chamber here. So let's put that back together and let's see how easily it goes back into place. So we're going to just push that back onto here, and then I'm guessing we just press this button and it should all just assemble back together. Well, that seemed fairly straightforward. So the Hakko does come with some accessories, so let's take a close look at those. The first of them being this stand. Now I've got to admit, I dislike this on site, and having watched a few reviews of this desoldering gun, pretty much everybody universally hates this stand because, yeah, well, it just feels quite small and not really appropriate. I would much rather have kind of a traditional holster that we could drop this in, but I'm guessing that the idea of this unit, it is designed to be portable, so maybe some people don't want to carry a large holster, but yeah, this doesn't feel very secure. It just feels as though, well, Yeah, I don't know. I'm kind of guessing that this is probably made from stainless steel and the whole thing is probably going to get pretty hot. So yeah, I don't really like the look of that, but that's what it comes with. So we've got what looks like a little screwdriver here. It's certainly got a flat tip on it, but I believe what this is for, this is actually for cleaning out the actual heating element, or the hole that goes through the middle of the heating element. And it comes with another tool which is also a cleaning tool, but this one is actually for cleaning out the nozzle at the end, because this unit does actually come apart. In fact, that's what we should try next. So this other tool that it comes with, this is actually for dismantling the actual heating element and removing the nozzle, because really you could do with buying a selection of nozzles. I think that the unit comes with a 1mm nozzle out the box, but I'm sure that we're going to have to buy some more to get the full range of use out of this equipment. So I believe the way we do it, I'm going to try it for the first time, is we push this down and twist. Actually, that was very easy. And then this sleeve comes off, and then we can see that this is actually the nozzle here, which actually does the desoldering. So as I mentioned earlier, you've actually got to get the right size nozzles depending on the component legs. So this is the tool for actually cleaning out the nozzle itself, but the actual heating element, apparently this is the tool that you need to use. So as you can see, it is actually hollow inside, because that's where the hot solder is going to go. Let's see how easy it is to put back together. Now apparently this tool is actually heat proof. You can actually change these nozzles when they're hot, but I've got to admit I don't really like changing soldering iron tips when they're red hot. I'm usually not quite that desperate. But yeah, that system seems to work really easily. I've certainly had more trouble removing soldering iron tips in the past. That's really good. The unit also comes with a bag, and it's got 2 spare ceramic filters and also what they describe as a pre-filter. So this is like a little metal, kind of like a little metal pan, and I think the idea is that when the molten solder gets sucked up, rather than hitting the plastic body here, that actual hot solder probably splats along the top of this little metal dish, and maybe it helps it solidify more quickly. So they actually describe that as a pre-filter. And then the unit itself here has a little separate filter that we saw at the back earlier, didn't we? So we've got some spares for that if we should need them. So going back to the bottom of the handpiece here, we do have this temperature adjustment wheel, and we can see that this actually goes from numbers 1 to 4, and printed on the side of the unit we can see we've got the various temperature ranges. So setting 1, it says that it's 350 degrees, setting 2 is 400 degrees, setting 3 is 450, and the top temperature is setting 4, which is 500 degrees. Now you can probably also see this little hole in the body of the unit, so that's actually a temperature calibration pot. So again, you can actually take this tool here, and what we can do is we can actually tweak the temperatures for those of you that want to set it absolutely precisely. So just taking a look at the cable that comes out of the unit here, I can actually see that it's got a number on it, which I do recognise. So it's got a HO5RR-F cable. Now interestingly enough, what this is it's a flexible rubber cable. It's the kind of thing that you might find on, well, kitchen appliances and stuff of that nature. But interestingly enough, it's not actually a heat-proof cable. It's actually only rated to about 60 degrees. So I don't know about you, but I'm rather surprised that on a piece of equipment like this, they haven't bothered to put something like a heat-proof cable, maybe something manufactured from silicone, or something maybe with a heat-proof sleeve on it, because of course it's quite likely that this cable could somehow come in contact with the hot heating element, and if this cable is only rated to 6 degrees, that's going to melt through and it could put you in a bad situation. The other interesting thing is the plug itself, in that what I would call this, it's a traditional rewirable plug. It's unusual that most plugs that I see on equipment these days are actually moulded on, aren't they? So I'm kind of guessing that, I don't know, maybe they don't sell enough into the British market to bother moulding a plug onto the end of here, but that's a bit of a strange one, isn't it? So let's go ahead and switch the unit on using this well, quite difficult to reach push button here. Maybe that's a safety feature. So I have pressed that in, and I can see that at the front of the unit now we've actually got a little red power indicator lamp that's lit up, although I've got to admit it isn't actually lit up particularly brightly. Can you see that? I'll switch it on and off. So that's off. That's on. It's not very bright, is it? Taking a look at the watt meter here, we can see that the actual reading on the watt meter, it does tend to vary somewhat, so we can see that it's actually pulsing the power to the heating element just to maintain the correct temperature. It looks to be around, I don't know, maybe 127 watts there, but I have seen it vary between about 110 and 130 watts. But I'm guessing that when I pull the trigger, it's going to draw a little bit more power because it's going to turn the vacuum pump on. So in fact, I'm just going to press the button now. Let's look at the wattage, see if it goes up. Okay, so with the vacuum pump running, it jumps up to about 150 watts. Now, according to the instructions, it actually takes about 1 minute for this actually to heat up to its desoldering temperature, but I would actually say it's considerably faster than that. It seemed to reach about the right temperature after 30 seconds. Now, it does say that when the unit has reached full temperature, you'll be able to see the light here on the amp piece, and it starts to pulse on and off as the temperature element is switched on and off here. And again, I think that actually started to pulse on and off after about 20 seconds. Now, at the moment, I've actually got the unit set to, well, it's set to temperature 1 at the moment, so that should be a temperature of 350 degrees. So let's just see if we can just go ahead and try that using this soldering iron thermocouple. Now, it is actually showing a little bit lower than that at the moment. It's actually just showing 305 degrees, but that could just be because we're not actually making a very good contact here with a thermocouple probe. A little bit hard to get the tip onto here. Let's go ahead and try temperature setting 2, which is 400 degrees. And again, it is actually reading a little bit low. Rather than reading 400 degrees, it's actually reading 337. Let's go to temperature setting 3, which should be 450. And it's measuring 433. And finally setting 4, which should be 500 degrees. Whereas we're actually measuring around 468 degrees, so again slightly under. So I'm just going to see if we can tweak this unit up a little bit, not sure which way to go. Well, it appears that the fine temperature adjustment really is quite coarse, but after a little bit of trial and error, I've managed to set it to about 407 degrees. I'm going to call that more than close enough. And down through the ages, a question asked by men, will she suck? Okay, minus 80 kPa. And a high-cost professional desoldering station manufactured by Pace. Well, because it's a first day, I'm just going to take a little bit of time to clean my nozzle and give it a bit of a tin. And let's try it on this single-sided board to start with. And I'm going to try to repeat some of the tests I did previously. So let's have a go at this transistor first. So that was actually set to about 370 degrees there, but it did feel as though it was just a little on the cold side, but it certainly had absolutely no problem whatsoever removing this transistor. For those of you that haven't used a heated desoldering tool like this one, there is a little bit of a technique to it. So the first thing that you have to do, and I'm going to do this in slow motion, what you actually do is you have to bring the tip or the nozzle up to the solder joint and put it over the leg of the component so it completely covers it, and you'll find that the solder will melt pretty much immediately. And then what you need to do is you need to engage the vacuum, but as you're vacuuming, what you actually have to do is you've got to just wiggle the nozzle here, kind of going a little bit of a circular motion, and that's just to ensure that we actually suck up all the solder that might be clinging to either side of the component leg. So I'm wiggling and now going to turn the vacuum on, and all the solder is sucked up into the reservoir of the solder sucking tool. Let's do that again, a little bit faster. Molten, wiggle, I think the hardest part is actually finding the joint you want to desolder, so I think that's the one. Now, one thing you might have heard there, that the desoldering gun was actually making a little bit of a different noise there, because what it was pulling a harder vacuum, and the reason that it was pulling a harder vacuum is that the leads are actually quite a lot bigger on these resistors than they were on the transistor, so we weren't getting as good a vacuum through onto the pads because the actual nozzle was being pretty much clogged by the size of the pins on the resistor. So I did mention earlier that probably when you start using these desoldering guns, you are going to need a selection of nozzles. This one is about 1mm, and it's probably about the smallest nozzle that I would want to use for the kind of things that I do. I probably want something bigger, because I certainly know that it isn't going to fit some of the larger components on here, maybe like this connector. I think that our 1mm nozzle is going to be more suited to the ICs on this double-sided board, but one problem I've noticed with the legs on these ICs is that some of them have been bent over at 90 degrees when the board was assembled. So I suspect what probably happened, they probably had one person sitting at a table who was actually installing a lot of the components, and then they probably went on to be, I don't know, soldered by somebody separately, or maybe they actually sent them over a solder bath to solder these chips in. Not exactly sure, but certainly they've actually bent the legs over to actually just hold them in and stop them falling out. Well, the problem with that is we actually need the pins to be sticking straight up. If they're not sticking straight up, we can't actually get the nozzle, the tip, over the top of the pin, which is what we have to do. So what I'm going to do is I'm going to unsolder the pins that I can remove, and then we'll have to come back and straighten some of the legs. Tempting as it may be, you don't want to try to use the nozzle of the desoldering gun here to try to straighten these legs, because what you're going to do is you're going to end up damaging the plating, the coating on the desoldering nozzle, and again you're going to shorten the life out of it. So really what you want to do is you want to take a normal soldering iron, you just want to straighten those pins out. And of course you really shouldn't even use a traditional soldering iron as a crowbar, but sometimes needs must. As before, I'm just giving each of these pins a push test just to see if it'll move, and it looks like all the solder has been removed from the top side, although it is difficult to tell sometimes. It's just a little bit stuck somewhere. We'll keep going. I think that's it. Oh, and we appear to have got that out. Oh, but unfortunately I've noticed that I have actually managed to do a little bit of damage here, so I have ripped off one of the pads. So it looks like one of these, in fact, yeah, I can actually see that one of the legs on the IC here, it's still got the pad attached to it. So unfortunately, what I would say is I've done an awful lot of desoldering over the years, and occasionally you will just have the odd casualty of war. It's unavoidable whatever you do. The only way to avoid this type of damage, and especially on boards like this where the pads are very old and the glue was probably not very good in the first place, I would generally just cut these ICs off. So I'm not actually going to blame the desoldering tool. But I think another of the problems is maybe this tip that I'm actually using is perhaps just a little bit too big for the pads, and we were losing some vacuum. Well, just for a comparison, I decided to test my Pace SX90 handpiece against the Hakko FR-301, and I've actually got to say that the two units do actually seem to compare really quite closely. Now my Pace station here, I've actually got a slightly smaller nozzle. I've got a 0.8mm nozzle, which should be an advantage, but what I've actually found is that neither of these two desoldering systems actually fully manage to remove the solder from the top side of the circuit board. Sometimes they do, sometimes they don't. One thing I have noticed about the Hakko is though that the vacuum on here is noticeably very much stronger than it is on the Pace station, so I think that's an advantage. I'm guessing one of the reasons that it's stronger is that the actual vacuum pump is actually built into the handpiece, whereas the vacuum pump on the paste station here, it's actually remote built into the main desoldering station. So yeah, the vacuum is certainly a lot less on the paste than it is on the Hakko. So yeah, the Hakko definitely does score on that. Well, I've been using our Hakko FR-301 in the workshop now for the last few weeks, and I've actually done a variety of jobs with it. Probably most of the work I've been doing is using single-sided circuit boards similar to this one, and what I've found is that whether it's resistors, transistors, or in fact IC packages on a single-sided board, I've had a first time 100% success rate. Absolutely no problem whatsoever. But going to double-sided boards like this, and especially ones that are double-sided with through-hole plating, I would say that my success rate has been quite a lot less. I would probably call it around 70 or 80%, and that probably fits with my experience of using other desoldering systems. Now, going back to my paste desoldering iron here, this unit retails at probably just over £1,000, and in my opinion the Hakko FR-301 does actually work just as well. Now, the cost of the Hakko FR-301 is quite a lot cheaper than the paste, in that you can actually buy these on Amazon for around the £340 mark, but it is actually still quite a lot more expensive than some of the cheaper desoldering systems that you can buy, and I'm thinking of the one that's actually made by Duratool, which most people seem to have. Now, I actually think that this is quite a big step up on something like a Duratool. It's certainly an awful lot more powerful and does work an awful lot better, but the Duratool retails at just over £100, and this one is over 3 times the cost. So I think you really have to be doing quite a lot of desoldering to actually want to pay the additional money, because both tools will get the job done. Now, it probably goes without saying that whichever system you buy, they all work an awful lot better than using something like traditional desoldering pumps or soldering braid. So I think for hobby issues, the Hakko here probably is on the expensive side, but I don't think if you bought one, if you actually did shell out your £340, I don't think you would regret it. The actual tool itself feels very professional. It's certainly very solidly built. I think it'll probably last pretty much forever. The way you actually change the soldering iron tips on here, it's very quick and it's very easy. I think one of the only things that lets it down is this really awful stand. Again, for your £350, I think they could have actually included a better stand, and I think they could have also included just some spare nozzles with this unit, because unfortunately when it does come to these desoldering nozzles, one size does not fit all. You're going to have to buy yourself some extra tips. So I've already gone away and I've actually ordered a 0.8mm tip and also a 1.6mm diameter tip, because I think that's going to be useful for the sorts of components that I have to remove. Now, another thing about the unit, it is actually designed to be portable, so it is a single handheld unit, and I guess that combined with the stand, if you are the sort of person that still has to go out on the road to do repairs, not that I can see there's many people that have to do that these days, but it certainly is a very, very portable tool, and that's what it's designed to be. So overall, I actually think that the Hakko is a really quality product. Now, what score would I give it? Well, I think I've got to admit, in some ways I'd like to give it a 10 out of 10, but I am going to remove some points. So I'm going to remove a point for the absolutely awful stand that it comes with, so that drops it down to 9. And I also think that they could have actually included some spare tips with it, so that reduces the score to, I think, the number 8. So I'm going to give this an 8 out of 10. So on that final score, I think for today that'll do. So until next time, bye bye for now.